Hello Year 5 and welcome to your geography lesson. Now, we're continuing on with our mountains and glaciation topic, but we've kind of left the mountains bit behind now. Mountains are behind. We're going to start looking at glaciation and what glaciers are. So the first lesson today is looking at what is a glacier. Now, this lesson has been really nicely timed with some news that we had on Friday, which I'm going to explain to you at the end of the lesson, okay? So we're going to be looking at what is a glacier, okay? So we're going to have to look at identifying what a glacier is and understand that there are different types of glaciers. There's quite a few different types, so we'll see how well you catch up with it today. We need to be able to explain how a glacier actually forms, so how it starts, how it forms, how big it gets, but then we also need to think about how it actually moves, because believe it or not, glaciers move. Okay, they may move very quickly, they may move very slowly, but it's not always apparent to the naked eye to be able to see. Okay, so we're going to look at how they move as well. So first of all, what is a glacier? Okay, now a glacier is a large area of really thick ice that stays frozen from one year to the next. Okay, sometimes it might get bigger, it might then get smaller, bigger and smaller, but it remains as a really large, thick piece of ice. Now, thousands of years ago, over 30% of our Earth's surface was covered in ice, but obviously due to global warming and the rise of our CO2, our carbon dioxide levels, it's now only around 10%. And we know from looking at the North and South Pole that the ice caps are starting to melt, okay? Now, most glaciers are located, obviously, in the North and South Poles, but they can exist between very high mountain ranges, such as the Himalayas or the Andes Mountains. And obviously, we know that that's because they have their own climate, because of that high altitude, and that's why they have a lot of that snow caps on their mountains and the ice. Okay, so questions for you to consider as we go along here. What might make a glacier change size? So think about the times of the year, it could be the temperature. What might make a glacier speed up or slow down? Because obviously they move. Okay, so we're going to consider those questions in our lesson. So there are several different types of glaciers. Now I'm going to move me up here because I think I'm going to be in the middle of most of our pictures for this PowerPoint. So different types of glaciers. So glaciers are formed when the snow is packed down into ice. So you can imagine when we had the snow day a couple of weeks ago and we went outside, you scoop up all that snow and it's very soft, it's very fragile. But as you begin to compress and push that down, that turned into a snowball. Now, if you continued pressing that snowball down, it gets harder and harder and you'd eventually be able to turn it into ice. And that's why we don't throw ice balls, because they're really, really dangerous. But as you compact it down and push it down, it turns into ice. Now, over the years, that snow crystals accumulate year by year, and it means that the temperatures, temperatures never become high enough to actually then melt it completely, okay? So as it starts to melt and refreeze and melt and refreeze, those ice crystals get harder and harder, okay? So it never actually manages to melt the snow and the ice. They almost stay semi-frozen to frozen most of the time. Now, when a large amount accumulates, so comes together, okay, the snow is then under a great pressure from the weight because it's quite heavy. Have you ever imagined rolling a giant snowball to make the head of a snowman, trying to pick that up? My goodness, it's really, really heavy. So because that snow gets heavier and heavier, obviously that weight compacts it and gets further and further down, and that's how it then turns into ice. It becomes solid. Now, this is an example of an ice sheet. Okay, so it's a massive ice, okay, thick, thick layer of ice that covers areas that are greater than 50,000 kilometers. So we're talking a really big distance. Let's just put it that way. Okay. So this type of glacier here is what's called a valley glacier. Now, these are actually like streams of flowing ice. Okay, it's very hard to be able to see because it's completely frozen on the bottom and the top. It's almost like a river of ice that flows between it. Okay, now it's contained within the steep-sided valleys. Okay, so as the valleys have like the edges like this, obviously that glacier winds all the way down through that crevice or through that crack. And it's like a stream of that flowing ice. So that would move as it works its way down the valley. Now, here's an example of the ice cap. Okay, now this is what we've looked at in that previous picture. It's that large span of ice. Now, rather than it covering 50,000 kilometers of the land like the ice sheet would, this is an ice cap. So it actually is smaller than an ice sheet. So it's almost like a cap, like a hat that sits on it, but that grows and can get smaller and smaller. Okay, so that is what an example of an ice cap, and it covers less than 50,000 kilometers. Now, this here is a very interesting type of glacier. This is called a Piedmont glacier. Now, it flows out of the bottom of a glacier onto a relatively flat plain, okay? Now, here you can see it's come down through this crevice of almost like a valley. And what's happened, it's then spanned its way out like a fan. Okay, so you imagine like when a volcano erupts and you see that lava coming down and it starts to spread out. Okay, this glacier does exactly the same thing. As that melts and compacts down that crevice, it then fans out at the bottom. So that's called a Piedmont glacier. Now, this glacier here is probably one of the most common ones that you know of, and we're going to recap this at the end of the lesson. So this is a calving glacier. Now, it occurs when a glacier, however you want to say it, flows out over the sea onto the water. Okay, and when these fall off or these break off, this is how we get the icebergs. Okay, so they actually tend to form what's called the ice shelf. So obviously it's that massive sheet of ice that is almost effectively on the edge of the water. Well, it's on the water, but that edge obviously then goes out into the ocean. Okay, but it's actually floating on the water. Okay, and they range from 100 meters long up to kilometers long. So we have the ice shelf in the Arctic, in the Antarctic at the moment. I'm going to show you an example of this at the end of the lesson. Now, when these start to break off, this is what forms those massive icebergs that then float off into the ocean. Okay, these are incredibly high and they are incredibly thick as well. They're up to 150 meters thick. So imagine if you ever run the 100-meter sprint on sports day. It's that and half of that length again, high. So it's incredibly thick ice. Now here we have what's called a Tidewater glacier, okay? Now this is almost because it like creates almost like a tidal wave that comes in. So this is when the glacier, the valley glacier, flows far enough to actually then reach the sea. So it's come all the way down through the valley, down through the mountains, but it's managed to get far enough to actually reach the sea, reach the ocean. Now, just like with the ice shelf, big chunks of this will fall off, okay, and it will break off, it will snap, and then they'll float away into the sea. So that's another way that we get the icebergs, which obviously are big, giant floating pieces. Now, what you need to remember, though, you don't just see the ice on top. That ice is also very deep under the water as well. And usually more of the icebergs that we see are under the ocean, obviously, because they start to melt more. So there'll be a big chunk of that ice that's underneath it then breaks off. So the Tidewater glacier is this glacier that gets to the tide, so the water's edge. Now, this one is called a circ glacier, okay? Now, this is the most common one that appears between mountains, okay? Now, they're more commonly known as mountain or alpine glaciers, and that's because they form on the slopes of mountains, okay? So it's not just having the thick snow like you might get on the Alps where people go skiing, but this is when they form into that solid block of ice, okay? And they start to travel down through those mountain slopes. Now, obviously, if that gets far enough down to reach the waterbed here, obviously that'd be a Tidewater glacier. But here is when it sits nicely in between those folds, okay, on the slopes of the mountains. Now, this is my favourite one just because I think it looks incredible. Now, this is called a hanging glacier. Now, I'm sure you can imagine as to why it's called a hanging glacier looking at this picture. So it formed on the side of a sloped mountain above a valley. So you can see here that this mountain sloped down and then it dips into the valley. You've got two waterfalls that come out here, but it doesn't peak or go beyond that valley. It doesn't manage to fall into the valley and then make its way to the water. So they're called the hanging glaciers because they never actually reach the valley. So the main glacier will actually be down here, okay, in another part of the valley, but it actually makes its way all the way down here and then stops. It doesn't go any further, so it almost hangs over the edge of the valley. Now, this one here, this is called an ice field. This isn't necessarily a glacier as such, but it's a big span of ice. So this is when it completely covers a flat surface. So obviously our glaciers are usually up in the mountains, they're in valleys, but this one here is almost a glacier because it's across entirely flat land. So an ice field, imagine like a field when you go out to a football pitch, it's on a flat piece of land, isn't it, a field? So here it's exactly the same thing. It's when you've got a flat piece of land that's made of ice. It's completely covered in that thick layer of ice. Now I'm going to show you an example here of how our glaciers move, and it might help make sense as to how they come down the valley and they reach to the water.
The sheet of ice that covers Greenland contains enough frozen water to raise oceans by 25 feet across the globe. As the planet warms, glaciers melt, causing sea levels to rise. But not all of that melt happens at the surface. In the summertime, Rivers and pools of meltwater find their way down through the glacier to the bed below. From there, the water runs beneath the glacier until it reaches the ocean. Because meltwater contains no salt, it weighs less than ocean water and rises up the front of the glacier in what scientists call a plume. Around Greenland, oceans are cold and fresh near the surface and warm and salty at depth. As the plume rises, it draws in the warm, salty water, melting the glacier face from the bottom up. Eventually, a piece of the glacier breaks off, making an iceberg in a process known as calving. As the oceans warm, calving speeds up, causing glaciers to retreat and flow faster. Faster glaciers dump more ice into the oceans and drive sea levels higher across the globe.
Okay, so you can see there how that water underneath trickles through. So you can see actually how far that glacier went below where the sea level was, and it went down all the way to the waterbed. Because that warmer water was trickled underneath, because it's ice water, it becomes fresh water, not salt water. And obviously at the bottom of the ocean is where we have the salt water. And that's where it starts to heat up that water and it starts to chip away at the bottom of the iceberg. And if you imagine if your iceberg's like this and you start chipping away at the bottom of it, that's going to get further and further and further like that. This becomes top heavy, and that's why this then cuts off. So that top bit of the iceberg then cuts off. That's the carving bit that I told you about, where it cracks off into a big giant iceberg. Now, just having a look at this picture here, I want to think about how this links to a glacier moving. Now, this is actually a tunnel or a cave underneath a glacier. And here you've got almost a tunnel of water. Okay, so this is that water that's melting underneath the glacier. And as that water is trickling through, it's warming it up from the inside out. So that temperature rise and that bubbles are the bubbles of gas, which are then warmed, so the CO2 gases that are coming into that water, that's going to start warming it up. And obviously as the bottom of it melts, it moves. Now, going back to our science experiment, remember when we did the science experiment with the ice cube and we had one in the frying pan and one on the board? That one on the frying pan started melting. Obviously, as it melted, that ice cube started moving, didn't it? So that water level underneath the iceberg is what drives it. That's what allows an iceberg or the glacier to actually then be able to move. Now, here's an interesting fact about a glacier. This one is called blood falls, okay? And this is actually found in the Antarctic, and it gets its name from that red-coloured water that flows down like a river. And the reason why it's called blood falls is because it symbolises, or it resembles the colour of blood, okay? Actually, when they did experiments on this, they found out that it was actually very rich in iron, okay? Iron saline water, which is salt water, and actually came oozing out from the glacier. So actually, although it wasn't blood or a special, miracle of water, it's actually only red because it was really, really rich in the iron, okay? But that's an interesting one there because it flows a different colour from what the ice is. Now, linking this back to Friday's lesson, the reason why this is so important was on Friday, a 490 square millimetre block of ice actually broke off our ice shelf in the Antarctic, okay? Now, there were cracks that were detected in it over a decade ago, and on Friday, that crack suddenly got a lot bigger. You can see the picture here, it widened up to 100 metres and then broke off. You can see how far it goes. This is an aerial view from a helicopter up here. You can see how far that goes all the way off the ice shelf. You see a picture of it here. It's this massive lump here that cracked all the way around. This bit has now come off, okay? Now, this is an example of carving, okay? You know when I mentioned that it breaks off because it's warmed up underneath and it breaks off into a big ice cube? That's exactly what's happened. But over the last 10 years, it's got a bit wider and wider. But on Friday, it widened over 100 metres and then completely broke off. Now, the interesting thing about this, okay, just to give you an idea of how big this is, this piece that's fallen off here, that's come off this entire ice shelf in the Antarctic, is a little bit bigger than London. So it is a massive piece of ice that's broken off, and it's over 150 millimetres thick, okay? So obviously they're going to have to now start tracking that to see whether that's going to cause any potential issues, because that's a lot of ice that's being dumped into the water, so it's going to increase the sea levels. But it just goes to show what's happening with global warming, that such a massive piece has broken off that ice shelf. Now, there's no task for you to do today because I felt like the tasks that I could have potentially got you to do were going to be really, really difficult for you to be able to do at home. So I've been lucky to you. I've been nice to you today. I've let you off with an activity, okay? But we will recap this when we come back and do this on our geography lesson for next week. So that's your last geography lesson for home learning. So we're going to be looking more at these glaciers and looking more at the topic when we come back to school next week. All right. So well done for paying attention to it, but remember it all because I'm going to test you on it when we come back to school next week. All right. Well done. You're fine.